Hello everyone, my dear friends, how are you all? This is Ayush Jain and I welcome you all to EDUCATA Accomplished Learning, the brand new session on that topic only, which is known as light, basically for class 10th students in the category of science. And today we are going to discuss about the spherical mirrors. Yes, we are going to talk about the spherical mirrors. We are going to draw the ray diagrams of the spherical mirrors. We are going to look towards various terminologies for the spherical mirrors, and we are going to look towards various other things also. Okay, so let us just start with the spherical mirrors. Now, what is a spherical mirror? Okay, are you serious? Yes, I just told you in the previous lecture that what is a spherical mirror. And this spherical mirror is basically a mirror which is having a curvature and which is polished from one side and it reflects from another side. Okay, that is only a spherical mirror. Now, a spherical mirror is a piece of a sphere. Okay, suppose that this is a sphere. Okay, perfect circle. Yes, it is a perfect sphere. Okay, so what we are going to do, we are going to divide it into two parts. Okay, we are going to divide this sphere into two parts. How? See, it is divided into two parts. Correct. Now, this is the first part. Okay, this is the first part in which we are going to polish the surface from this particular side. Okay, we are going to polish the surface from this particular side, and hence this mirror becomes what? This mirror becomes a concave mirror. Which mirror? Concave mirror. Yes. Okay, so this basically gives us the concave mirror. Now, in the other case, in the second part, what we are going to do? We are going to just polish this surface from this particular side. Okay, we have just divided it into two parts, and now what we are doing? We are just polishing this surface from this particular side, and this particular mirror, this particular sphere gives rise to what? It gives rise to the second part, which is known as what? Which is known as the convex mirror. Okay, so we just got what is a concave mirror and what is a convex mirror. This is the reflecting surface. Okay, the inner portion is the reflecting surface and the outer portion is basically known as the polished surface. Okay, this is the reflecting surface, this is the polished surface. In the case of convex mirror also, this is the reflecting surface and this is the polished surface. If I just draw a smaller view of this particular mirror, what we are going to get? Yes, this is basically a convex mirror. Okay, and this is basically a concave mirror. Okay, there are two types of spherical mirrors, which are convex and concave. We are now going to look towards various terminologies for these mirrors. Okay, why I am drawing this line? Why I am drawing this line? Because this line which is passing from the center of the mirror, the line passing from the center of the mirror, this is known as the principal axis. So the first terminology that we are going to get is the principal axis. I think I should write all the terminologies over here. So the first terminology is basically the principal axis. Okay, it is the principal axis. Now, there is a point in both the mirrors where the line is intersecting the mirror. Okay, this line is intersecting, this principal axis is intersecting the mirror at this particular point. Okay, it is intersecting the mirror at this particular point. So this particular point is known as the pole of the mirror in both the cases. Okay, and I am representing this pole by capital P here also. This is the pole of the mirror, which I am representing it by capital P. Okay, this thing is also clear. So the second thing that we saw is the pole. Okay, so the second thing we saw is the pole of the mirror. Okay, clear. Now moving ahead, what is the another thing? See, this is a complete sphere. Okay, this is a complete sphere, so it might be having a center point somewhere over here. Don't you think? It might be having a center point somewhere over here where from which this distance is equals to this distance is equals to this distance is equals to this distance. Okay, there might be a center of the mirror. Okay, so here also there might be a center of the mirror from which all the distances are equal. Okay, so suppose that this is the center of this particular mirror. Okay, this is the center of this particular mirror. This center of the mirror is known as the center of curvature. I am representing this center of curvature by a capital C. Okay, so the third terminology that we understood is basically what? It is the center of curvature. It is known as what? Center of curvature. Now, there are some more terminologies. Here also, we are going to get the center of curvature somewhere over here. The another term that we are going to get is the radius of curvature. What is this radius of curvature? By radius of curvature, we basically mean that the distance between the pole and the center of curvature. Okay, so the distance between the pole and center of curvature, let me mark it over here. This is known as what? This is known as the radius of curvature. Okay, here also this particular distance is known as the radius of curvature. You may write the definition that the distance between the pole and the center of curvature in any of the mirrors is known as the radius of curvature. So the four terminologies become what? How much time I am speaking the same thing. This is known as the radius of curvature. Okay, actually I am speaking these things multiple times so that it gets in your head and it fits in your head, and then in the examination you can just spill it out. Okay, a simple thing. Wow, I am teaching for multiple times in my lecture, at least 4 to 5 times, so that all the things can get in your head. That's a good point. Okay, the radius of curvature. Okay, the another thing that we are going to get, suppose that a ray of light is incident on this particular point. See, in the case of a convex mirror, the center of curvature is lying at the right hand side of the mirror, and in the case of concave mirror, the center of curvature is always lying at the left hand side of the mirror. So you just have to remember this particular point, that in the case of convex, center of curvature lies on the right, and in the case of concave, center of curvature lies to the left of the mirror. Okay, now suppose that this is the ray of light which is passing from somewhere over here. Now it will go something like this. We will learn how to draw the ray diagrams, but for your convenience, I am just showing you one thing. Suppose that this is a ray of light which is passing parallel to the principal axis. This ray of light is passing parallel to the principal axis, and it will pass through a point somewhere like this. Now, the rays of light which are passing parallel to the principal axis will always pass through the same point. Okay, they all are going to pass always through the same point, and this particular point is known as what? This particular point is known as the focus. Okay, this is known as the focus, which I am representing it by capital F. In this case also, what will happen? In this case, suppose that a ray of light is coming something like this, and it is striking the mirror at this particular point. From where it will pass? It will pass through this point. Suppose it will pass through this point. Okay, after this, what will happen? Suppose that a ray of light is passing something like this. It will again pass through the same point. Okay, so in this case, this particular point is known as what? This particular point is known as the principal focus, represented by capital F. This is the principal focus. So the another terminology that we just learned is what? It is basically the principal focus. Clear? Now, some more terminologies are left, such as focal length. What do you mean by a focal length? By the word focal length, we can say that the distance between the principal axis, okay, the distance between the principal axis and the focus, that distance is known as the focal length. In this case, this particular distance, okay, in this case, this particular distance is known as focal length. I am representing it by small f. Okay, in this case, this particular distance is known as the focal length. I am representing it by small f. Okay, So I think you got to know what do we mean by focal length, and all the other terms, what are their meaning. Sixth term, what is it? Sixth term is basically focal length. Okay, I think that you might be clear with all these terms that I have just written over here. One more term is remaining. What is it? That is the aperture of the mirror. What is the aperture of the mirror? The actual length of the mirror, or the actual size of the mirror, that we call as the aperture. Now, what do we mean by size over here? Does it mean diameter, or the radius, or the perimeter, or the area, or the volume in this case? What is the aperture of the mirror? The aperture of the, for making the aperture of the mirror, you just have to do a simple thing. What do you have to do? You just have to mark the endpoints of the mirror. Suppose this is the endpoint of this, and suppose this is the endpoint of this. Here also, this is the endpoint and this is the endpoint. These are the endpoints of this particular mirror. Then what you have to do? You just have to sketch a line. Sketch a line joining these 2 points. Okay, joining these 2 points. So we just have sketched a dotted line which is joining these 2 points. In this case also, this is the line which is joining these 2 points. Now the length of this particular dotted line, that only is named as the aperture of the mirror, and I am representing this aperture of the mirror by the letter capital A. Here also by the letter capital A. What is this capital A? This capital A is the aperture of the mirror. Just get it in your head that this is known as the aperture of the mirror. Okay, so this was basically the last term of the basic terminologies, and seventh term, which is known as the aperture. Okay, I think that all these terminologies might be clear to you. Okay, in case of any doubt, you can always comment me in the comment section, or you can just follow me on you can just subscribe to our Telegram channel. The link is given in the description. You can follow me on Unacademy. The link again is given in the description. You can follow me on Quora. Link again is given to the description. You can subscribe to this channel. You can press the notification bell, and I think I am on these much platforms only. Okay. I can't do anything else. So these are the basic terminologies that we have learned for the case of a spherical mirror. Now, what is the main motto of this lecture? We have to learn how to draw the ray diagrams for any of the mirror, may it be convex mirror and or may it be concave mirror. So there is a proper procedure of how can we draw a ray diagram. Okay, so first what we have to do? First we have to learn about the rules for drawing the ray diagram. The rules, or you can say that there are certain statements by using which we can easily draw the ray diagram. Okay, so the first statement says what? The first statement tells us that whenever a ray of light passes parallel to the whenever a ray of light is incident, then the angle of incidence and the angle of reflection will always be equal. Ayush, this is the law of reflection. Yes, so we can use the law of reflection for making the ray diagrams also, can't we? Yes, we can use, no problem in that, because it is a law basically. So the first law says what? First rule says what? First rule says that angle of incidence will always be equal to angle of reflection. Means, suppose that I am just considering the case of the concave mirror only. Okay, for convex mirror also same thing is there. Okay, for concave and convex, or I think I should consider both of them so that there is no confusion. So suppose that this is a concave mirror. Okay, this is a concave mirror. Okay, and suppose that here we are drawing a convex mirror. So this is a convex mirror. The first thing that we have to do is draw a principal axis. Okay, the first thing that we have to do is draw a principal axis. This thing is new for you. That's why I am going with the very basics. Okay, in this case also draw the principal axis. So we have just drawn the principal axis for both of them, and now what we are going to do? We are going to draw the we are going to mark the pole. Yes, this is the pole. In this case also, this is the pole. Then we will mark the focus and the center of curvature. In this case also, we will mark what? This will be capital F, because small f I will represent the focal length. Okay, so this is capital F. In this case also, we will mark the focus and the center of curvature, something like this. Okay, they will be marked something like this. After this, what we have to do? After this, we are just drawing a ray. We are just drawing a ray. Suppose that this is the ray. Okay, and it is basically incident where? It is incident on the pole. Okay, it will be incident on the pole. Suppose that here it is having an angle of I. Okay, this angle is I. Okay, this angle is clear. This angle is angle of incidence. What will happen? It will just strike the surface, and this ray of light will reflect back for taking an angle R, and this small r is basically equals to what? This small r is basically equals to capital R in this case. Okay, because we know that angle of incidence is equals to angle of reflection. In this case also, a similar case. Okay, this is also similar case. Suppose that this ray of light will pass something like this. Okay, this ray of light is passing somewhere over here. Suppose that it just makes an angle I, angle of incidence as I. If we are just taking the angle of incidence as angle I, what will happen? Again, in this case, the ray of light will get reflected something like this. Okay, and it will make an angle of R. And we all know that angle I will always be equal to angle R. So this is the first rule that we have to apply, that angle of incidence will always be equal to angle of reflection. The second rule that we are going to look to is pretty simple, because we just applied that rule somewhere over here. Yes, in this case and this case. Second rule tells us that whenever a ray of light, okay, I am writing it over here. Whenever a ray of light passing parallel to the principal axis. Okay, what? Ray of light passing parallel to the principal axis will always pass through focus. I think the ink is getting out, but no problem. Through the focus. Okay, means what? Means a simple thing. What you have to do? You have to just draw the ray diagram something like this. This is our concave mirror. Okay, and then this is our convex mirror. This pen is working fine. Then what we have to do? We have to just draw the principal axis. This is the principal axis, and the point on which the principal axis and the mirror intersect is known as the pole. Here also, this is the principal axis that we are going to form. So this is the principal axis, and this point is known as the pole. Then what we do? What will we do? We will mark a focus. We will mark a center of curvature. Here also, we will mark a focus, and we will mark what? A center of curvature. Then what we have to do? We have to pass a ray of light. We have to pass a ray of light parallel to the principal axis. Okay, this ray of light is passing parallel to the principal axis, somewhat like this. And if a ray of light passes parallel to the principal axis, it will always pass through the focus. Okay, so this ray of light will always pass something like this. If suppose that a ray of light was passing from over here, then what will happen? Yes, then again it will pass always through the focus, something like this. So a ray of light passing parallel to the principal axis will always pass through a focus. You just have to remember this statement, and you just have to remember these diagrams which I have made for a concave mirror as well as a convex mirror. In this case, what will happen? See, this ray of light is passing parallel to the principal axis. It will always pass through focus, and this ray of light passing parallel to the principal axis will always pass through the focus. Okay, this is the diagram that we got. Means any image if the object is placed at infinity and we are making the and we are just passing the rays of light of that particular object parallel to the principal axis, it will always pass through the focus and we will get the image somewhere at the focus. Okay, this point might be clear to you. Now the third and the last statement that we are going to look towards. Okay, so the third statement basically tells us that, okay, I think I should write with a blue pen because this black pen is not working. So the third statement tells us that whenever a ray of light passes through the center of curvature, whenever a ray of light passes through the center of curvature, it will just retrace its path. Suppose that the ray of light was passing something like this, it will just come back like this, like this, like this, like this, like this. Wow, good game. Now, so I'm just writing that particular statement over here. But first, you just have to look towards this statement also. See, I told that the ray of light is passing parallel to the principal axis and it will always pass through focus, but its vice versa is also correct. Okay, its vice versa is also correct. How? If a ray of light is passing through the focus, then that the reflected ray will the reflected that we are going to get will always be parallel to the principal axis. Okay, if a ray of light is passing through the focus, then the reflected ray that we are going to get will always be parallel to the principal axis. So you can write it over here like and vice versa. VICE, Vice President of India, and versa, verse. Okay, versa. Versa is a shoes company, I think. Yes or no? And it is spelled something else, but I just spell it like verse. Anyways, I don't know anything about it. After this, the third point, again I am just writing when a ray of light passes, how it passes, PASSES, he just passed away, passes when a ray of light passes through the center of curvature, then it will retrace its path back. Retrace its path. How come? I am showing you, no worries in that. Okay, suppose that this is the concave mirror that you are having, and suppose that this is the principal axis of this particular concave mirror. Then here we are having a convex mirror, simple. Then we are having here a convex mirror. Okay, shape just got distorted, so just erasing and drawing this new one. Okay, now what is this? This is a convex mirror, as you all can see. Wow, what a beautiful diagram. This is the diagram of a convex mirror. What a beautiful diagram. Beauty, beauty, beauty. Now what will we mark? We have to mark the pole. Okay, here is the pole. Here we are getting the pole again. Here we are getting what? Here we are getting the focus, which is which I am representing by capital F. And here, or okay, somewhere I have taken capital F, somewhere I have taken the small f. But in this case, I am representing it by capital F. Here also, we are getting the focus, which is represented by capital F. Here we are getting the center of curvature somewhere over here. Here we are getting the center of curvature somewhere over here. Okay, done. What will we do? We are just going to pass a ray of light through the center of curvature. Means a ray of light, suppose that it is passing somewhere something like this from the center of curvature, then what will happen? This ray of light is going to retrace its path back. Okay, this ray of light is going to retrace its path back. Again, in this case also, what will happen? Suppose that this is the ray of light which is falling something like this. It will go inside the mirror to the center of curvature. Okay, after coming, what will happen? It will just retrace its path back. Okay, so in this third case, what will happen? The ray of light will always retrace its path back whenever it is passing through the center of curvature. Okay, now I think you are done with all the rules that we are going to use for the formation of ray diagrams, but in most of the cases we are going to use this second rule and the third rule only. Okay, this first rule I just told you because it is going to be used in the derivation for magnification of the mirror. Okay, that's why I just told you, but in most of the cases we are going to use this rule and this rule because it is pretty difficult to draw. We have to measure this particular angle, we have to just pass this ray of light from the principal axis, and we have to do various other stuffs. That's why we are going to use this and this rule only. Okay, so starting in 1, 2 and 3. Okay guys, so now we are going to draw various ray diagrams for various cases, for the case of concave mirror as well as convex mirror. Okay, so the first we are going to draw for the concave mirrors. Okay, first for the concave mirrors. Now the first case in concave mirror, what is it? What is the first case in concave mirror? In the first case, we are going to place the object is at where object is at infinity. We are going to place the object at infinity, and then we are going to look towards where is the image being formed. But we have just studied this case, so I am just drawing it. See, this is our concave mirror. Okay, this is the concave mirror that we are having. What is this? This is the principal axis, and this is the pole. This is the focus. This is the center of curvature that we are having. Okay, so pole, focus and center of curvature, you all have to mark like this also, like this only. Now what we are doing, we are taking the object at infinity, means object is present somewhere over here, here, here. We don't know where the object is present. We don't know whether the object is present in Mumbai, whether the object is present in Delhi. We don't know whether the object is present 100 meters away, 1000 meters away, 2 kilometers away, 1000 kilometers away. We don't know anything about the object. We even don't know that what is the size of the object. We don't know anything about the object. Okay, so what we are going to do, we are going to take the object somewhere at infinity. Okay, the object is present at infinity, we don't know about it. So what we are going to do, we are going to draw a line which is parallel to the principal axis. Okay, first ray of light which is parallel to the principal axis, and the second ray of light which is again parallel to the principal axis. Okay, both these rays are parallel to the principal axis. Now what will happen if these rays of light will reflect? Okay, the image that we are going to get, let me mark it with a different pen. The image that we are going to get will be formed, the reflected ray of light will be something like this, and from here also the reflected ray of light will be something like this, because the ray of light passing parallel to the principal axis will always pass through the focus. Just remember this point. Okay, means where are we getting the image? The image that we are getting, is at focus. Okay, first point we can write that image that we are getting is at focus. Okay, second point, the size of the image. What is the size of the image? The size of the image is basically negligible size. Negligible or very small size, you can say negligible size. And the property, its nature. What is its nature? The image being formed is real as well as inverted. Okay, the image being formed is real and inverted. But Ayush, how can you tell that the image is real and inverted? How is it possible? Here the image is formed at the focus. We are not able to look towards the image. Neither we are able to look towards the object. How can you say that the image will be real and inverted? See, the image which is formed to the left of the mirror is always going to be a real and inverted image. The image which is going to be formed on the right hand side of the mirror is always going to be virtual and erect image. Just remember this point. Okay, so in this case the image is being formed towards the left hand side of the mirror. So the image will be what? The image will be a real as well as inverted image. See, a real image will always be an inverted image. A virtual image will always be an erect image. Just remember this point also. Okay, so the image is real and inverted. Okay, Now the second case. Second case is what? When the object is present beyond the center of curvature. Okay, beyond the center of curvature. Are you able to understand my handwriting? Because I know that my writing is quite poor, but I think that all the things are visible to you, and actually I am speaking also, so you can just make proper notes from your side, because all these lectures are going to be very much comprehensive. These lectures are very much comprehensive and everything will be covered in very much detail. So you just keep your pen and paper or your notebook and paper, notebook and pen, and continuously you just make notes for the exam purpose. I can assure you that the notes you are going to make will be 100% coverage. Okay, everything is going to be covered in those notes. Now, talking about this particular case, we are going to make a concave mirror, something like this. This is what? This is a concave mirror. Okay, now we are going to mark the principal axis. This is the principal axis. This is what? This is the pole. This is the focus that we are going to get. This is the center of curvature that we are going to get. Now what will we do? Suppose that our object is present somewhere over here. This is the object that we are going to get, and let us name this object as object AB. Okay, the name of this object is object AB. AB is one of my friend. That's why I am keeping its name as AB. Okay, clear? You can keep the name as per your convenience, but just because he is my friend, that's why I just kept this name. Okay, you can use your notations also. Now what will happen? This ray of light, the ray of light, let me mark it with a red pen. The ray of light will pass parallel to the principal axis. Okay, this ray of light is passing parallel to the principal axis, and after passing parallel to the principal axis, it will always pass through the focus. Okay, so this ray of light is passing through the focus also. Now let us make the second ray of light pass through the center of curvature. Okay, it is just passing through the center of curvature. Or you can do what? You can just make another ray of light passing through focus and just make the line parallel. It is one and the same thing. You are going to get the image at that particular point only. You can just try it once. Okay, this is the ray of light which is passing through the focus. Okay, or let me represent it by a dotted line so that everything is clearly visible. This is the ray of light passing through the focus, and after passing through focus, it will pass parallel to the principal axis. So this is the line parallel to the principal axis. Yes, it is passing from here only. The point of intersection of the first ray and the second ray, it is passing through there only. Okay, so you can apply any of the rules that you want. Okay, no problem in that. You can apply any of the rules, and the image that we are going to get is somewhere over here. And this image that we are going to get is the inverted image. Let me name this image as A dash and B dash. Okay, this is A dash and B dash. This is the image that is formed over here. Okay, means what can we say about the nature of the image? Image is formed in between the center of curvature and focus. Okay, so you can write it over here, that image between center of curvature and focus. Okay, any other properties? Image formed is greater in size, larger in size? No, it is smaller in size. So the image formed is basically diminished. Okay, diminished. Any other properties? Image formed is real and inverted. It is a real and inverted image. So these are the properties of the image which is formed by the object which is present beyond center of curvature. Now another object that we are taking will be present where? See what we are going to do. We first kept the object somewhere over here. Then we kept the object somewhere over here. Now we will move further ahead and we will place this particular object at center of curvature. Now what? The object, third point, object is present at center of curvature in this case. Okay, so just look towards the image formation. First, what you can do, you can just try to make this image. Okay, you can just try it by yourself. It will be beneficial for you, because if you just try and you just commit certain mistake, then you can just resume the video and see how the image is being formed, and it will be just your practice. You will get a confidence that yes, you are able to draw the ray diagrams. Okay, so what you can do, you can just pause the video and just try it by yourself about how the image is going to be formed. Now moving further ahead, what we can do, we can just make a concave mirror, something like this. This is a concave mirror, and here somewhere we are going to get the principal axis. This is the principal axis, this is the pole, this is what, this is the focus, this is the center of curvature that we are getting. Now what will we do? We will take an object at center of curvature. Okay, we just took this object at center of curvature. This is the center of curvature. This object is at center of curvature. Then what will happen? The ray of light will pass first parallel to the principal axis. Okay, if the ray of light is passing parallel to the principal axis, where will it pass from? It will always pass through the focus. Okay, so it just passed away from the focus. And the second ray of light, how will we draw? The second ray of light, we will pass it through the focus. This ray of light is passing through the focus, and when it strikes the mirror, it will pass parallel to the principal axis, something like this. Okay, it will pass parallel to the principal axis. The ray diagram, I think I just did a mistake, or I just draw I'm just drawing it a rough diagram. But what will happen actually, this ray of light, this image will be formed at the center of curvature. Okay, this image will be formed exactly at the center of curvature. Or I can do it something like this. I can do the cheating. Yes, because I have not measured it properly. So the image that we are getting is formed at the center of curvature. We can name the object as AB. Okay, this object, let it be object AB. The image formed that we are getting is equals to A dash B dash. And we can see that these both triangles are congruent. And because of congruency, we can say that this AB, our object size is basically equals to A dash B dash. Why? Because the triangles are congruent, we can easily see that. Now, the properties of the image. If we write the properties of the image, where is the image formed? Image is formed at center of curvature. The size of the image, same size. The image is of the same size. And anything else? Yes, the image formed is basically real and inverted image. All these points are clear to you? Now, another ray diagram. First, you try it by yourself. Okay, I am not telling it. You just try it by yourself. When the object is present between center of curvature and focus. Okay, if the object is present in between center of curvature and focus, where will the image form? I am just giving you 10 seconds. You just draw it by yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not drawn. What are you doing, yaar? What are you doing? So let us just look towards this case. This is our concave mirror. Okay, this is our concave mirror. What will happen? First, we have to draw the principal axis. This is the principal axis that we are going to draw. And we have to just mark the pole over here, the focus somewhere over here, and the center of curvature somewhere over here. I'm just drawing it roughly. This center of curvature somewhere over here. See the distance between the focus and the pole and the center of curvature and the pole. The distance between center of curvature and the pole is 2 times the distance between the focus and the pole. Just remember this. Means you can say that the radius of curvature is 2 times the focal length. We will just derive the formula for this particular thing also. No problem in that. Now, suppose that your object is placed somewhere over here. Okay. Your object is placed somewhere over here. Now what will happen? The ray of light will again pass parallel to the principal axis. You can make it this ray of light passing parallel to the principal axis, then it will always pass through the focus. It is always going to pass through focus. The second ray of light, it is passing through the focus, and what it will do? It will go parallel to the principal axis. It will move parallel to the principal axis. The image will be formed something like this. Okay. The image that is being formed is something like this. Suppose that the object name is AB and the image name is A dash B dash. So now can you tell about the properties of the image? First, where is the image formed? Image formed, Now this blue pen is gone. What is happening? The pens are just going, pens are just dying. What can I do? I just use the refill in this black pen. Now this blue pen is gone. What can I do? So I am just using the black pen instead of blue pen. What is happening here? The image formed is beyond C. Okay, image formation is beyond C. First point, I think it might be clear to you. Now the next point. What is the next point? The size of the image. Is it smaller? Is it bigger? Is it of the same size? Yes, we can see that the size of the image being formed is larger than the size of the object. Okay, okay. So the size of the image is magnified. And any other property? Yes, we can say that the image formed is basically inverted image. Okay, the object is something like this, the image formed is something like this. So it is inverted image, and because it is inverted image, it is a real image also. Yes, good point, yo. So the image formed is basically real and inverted. Okay, so this ray diagram might also be clear to you. Now we are going to place the object at focus only. Okay, the object will be placed at focus. So the fifth point that we are going to look towards is that object is placed at focus. If we are just placing the object at focus, what will happen? Again, I am just drawing the ray diagram. Suppose this is a concave mirror, and suppose that this is the principal axis that we are going to get. This is our pole, this is the focus, this is the center of curvature. Okay, so what will happen? Let me just use this red pen because this blue pen is dead. This is our object. Because this is our object, where will the ray of light pass? The ray of light will pass. Now this red is also gone. Oh, what is happening? What is just happening? I don't know. This is the ray of light which will pass parallel to the principal axis, and because it is passing parallel to the principal axis, it will always pass through the focus. Blue pen started working. This tricks na, I don't know about it. So it will always pass through the focus. Let the another ray of light pass through the center of curvature. It is passing through the center of curvature. Okay. Okay, this is correct. So this ray of light is passing through the center of curvature. You will notice that these two lines will never meet. Okay, these two lines are never going to meet. They are going to meet at infinity. Okay, these two ray of light are basically parallel to each other. If you just draw a fair diagram, so you will find that these two lines are parallel to each other and they will basically meet at infinity. And because they are meeting at infinity, we can simply say that the image formed, okay, we can simply say that the image formed is basically at infinity. We are going to image at infinity, and the image formed will be highly magnified. Yes, the image formed will be highly magnified, or you can say tremendously magnified, or you can say that very high magnification. You can say anything. Okay, so it will be highly magnified image. Highly magnified. And the image will be a real and inverted image because it is being formed at the left hand side of the mirror. So it will be a real and inverted image. Okay, so all these points might be clear to you. Now, the last case, the most important case, because only this case I am going to talk about, only this case which is used in our daily lives. Okay, these case they are never going to be used, but this case, this is used in our daily lives. Oh, my pen's cap gone. Just picking it up. Yes, picked up. So the sixth case that we are going to look towards is basically what? Object between the focus and the pole. Object between principal focus and pole. See what is happening in this case. Suppose this is our mirror. Which mirror? Yes, concave mirror. What else? This is the principal axis. This is the pole. This is the let me mark the focus at a larger distance because we are just taking the object between the focus and the pole. This is the focus and this is the center of curvature. What will happen? This thing will happen. This is our object. Okay, this is the object that we are going to get. Let it be object A and AB. What will happen now? the ray of light will pass through pass parallel to the principal axis. Okay, let me just draw it with a red pen. The ray of light will pass parallel to the principal axis, and because it is passing parallel to the principal axis, it will always pass through focus. Yes, it will always pass, always pass to the focus. Okay, this is the first ray of light that we are going to get. Now let the another ray of light pass through the center of curvature. The another ray of light is passing through the center of curvature. See, these ray of light are something like this. Okay, something like this. If they just move back, they are going to never meet. Okay, but if we just try to do something that we extend the line farther away on the back side of the mirror, what will happen? They will meet. Yes. So what we are going to do, we are going to draw virtual lines. Okay, we are going to draw the virtual lines, something like this, and they will meet somewhere over here at the back side of the mirror. And because they are meeting somewhere over there at the back side of the mirror, we can say that the image formed is something like this. This is the image formed. Let the image be A dash and B dash. Okay, so A dash, B dash. In this case also I have not marked the image. This is the object AB. Image is formed at infinity. In this case, the image being formed is A dash and B dash. A dash, B dash is the image formed. Now, what can you tell about the properties of the image? What can you tell about the properties of image? See, the image formed, is it small? It is magnified? Yes, image is magnified. First the image formed is beyond the mirror. The image being formed is beyond the mirror. Okay, this is the first point, that the image is formed beyond the mirror. After this, the another point says that the image formed is magnified. This is not highly magnified, but we can say that yes, it is magnified a bit. Magnified. Another point, in this case, only in this case, the image formed is basically virtual and erect image. Okay, it is not possible in this case, any of the cases, but in this case, only in this case, the image formed will be virtual and erect image. Virtual and erect image. I am just making a box over here because this is the only important case that we are going to look towards in the case of concave mirror. In case of numericals, you might get various other cases, but in our daily applications, this is the only case that we are going to use. Okay, is this point clear to you? Now, another thing, yes, we are just done with the concave mirrors. Okay, this is all about the concave mirrors that we have seen. Now we are going to draw the ray diagrams for the convex mirror. Okay, now we are going to consider the convex mirrors. Convex mirror, only two cases that we are going to see, because there are only two cases possible. In each of the cases, the ray diagram that is going to be formed will be similar. Okay, so in the case of convex mirror, let us first take the object. This is a concave mirror. See, what am I doing? This is the mistake that I am doing, and this is a big blunder that I am doing. See, this is our what? Convex mirror. Okay, first we have to just draw the principal axis. So yeah, this is the principal axis that we have drawn. This is the pole, this is the focus somewhere over here, and suppose this is the center of curvature somewhere over here. What we are going to do, the first case that we are taking is that the object is present at infinity. Yes, we all know that when the object is present at infinity, it will always pass through the focus, and the image that we are going to get will be formed somewhere over here. Yes, image will be formed somewhere over here. Yes, this case we all know. Okay, so where will the image formed? Image formed at focus. Okay, image is being formed at focus. First case, the image is magnified, diminished. What is the possibility? Image is what can we say? Yes, of negligible size. So the image formed is of negligible size. Clear? I think that this point might be clear to you. Now, one more thing, what is the sort of image? See, the image is formed on the right hand side. So the image formed on the right hand side, we always take it as a virtual and erect image. The image formed is a virtual and erect image. We always have to consider this case that the image formed on the right hand side is a virtual and erect image. Okay, so this was the first case. The second case, are we going to take it beyond focus? Are we going to take it at center of curvature? Are we going to take it beyond center of curvature? Are we going to take it between the principal of focus, between the pole and the principal axis? What is this case? Comment it down below. Before I just start, just comment it down below that what is the case that I am going to take. Okay, let me tell you now. The second case that we are going to take it is kahin bhi. Okay, what do we mean by kahin bhi? Means you can place the object anywhere except infinity. This is the only case, kahin bhi. Okay, this is the word that we call kahin bhi. If you don't understand Hindi, kahin bhi means anywhere. Okay, if you don't understand Hindi, but I don't think that my lecture might be watched by those people who don't understand Hindi. That's the only case. So this is our convex mirror. Suppose that this is our convex mirror, shaded, polished from this particular region, and then what we are going to do, we are going to draw a principal axis somewhere over here. Suppose this is the focus, this is the center of curvature that we are going to get, and after that we are going to we are going to take what? Object, kahin bhi. Object will be present kahin bhi. It might turn into a song like kahin bhi, kahin bhi, kahin bhi. Okay, so what will happen? This ray of light will pass parallel to the principal axis and it will always pass through the focus. Okay, this ray of light will always pass through the center of curvature and it will just retrace its path. It will pass through the center of curvature and it will just retrace its path. And we are going to get the image where? Between the pole and the focus. Okay, we are going to get the image between the pole and the focus. The properties of the image that we are going to look towards is what? The properties of the image, we can say that image is formed between pole and the focus. Okay, this is the first property. Second property that we are going to look towards is what? The image formed is of a smaller size. Image formed is diminished. Okay, diminished, D-I-M-I-N-I-S-H-E-D, diminished. The image formed is diminished. Wow, nice word. Now, the another property that we are going to look towards is that image formed is basically a virtual and erect image. Okay, image formed is basically a virtual and erect image. So, all these cases are the cases that we have just discussed, and these cases are only useful to you in solving numericals. Okay, and if there is any other possibility of any other case, just comment down below in the comment section. And I can guarantee you that there is no other case that is possible other than these. Okay, now what we are going to do, we are going to look towards the uses of these mirrors, which are known as concave mirror as well as convex mirror. We are going to look towards its uses. And one more thing that I am going to tell you, but let me just clear this board till then. Okay guys, so let us just start with the uses of the concave mirror. Okay, uses of the concave mirror as well as convex mirror. So for the case of a concave mirror, C-O-N-C-A-V-E. First of all, tell me what is happening in the case of concave mirror. For the concave mirror, to get a virtual and erect image, what all we need? We get a magnified object. Okay, we get a magnified image of the object. Okay, and because we are just getting a magnified image of the object, what do you think? Where will be its application? Where will be its applications? See, the first application that you can look towards is basically what? By the doctors, by the dentist to check your body. Okay, so by the doctors. Another application in the lamps that we are using. Yes, the ray of light is going something like this. Yes, we are getting a magnified image. That's why in the case of magnifiers, in the case of, you might all have seen your fathers and mothers shaving. No, not mothers. Your fathers shaving how they shave? They just keep the mirror somewhere over here and they shave something like this. So that mirror that they are holding, what it does, it basically provides them a magnified image of their face. Okay, it is just providing the magnified image of their face to them so that they can easily look towards the mirror and shave properly. Okay, so it is basically used where it is used in shaving mirrors. It is used in solar panels. Okay, fourth point, it is used in solar panels to get more and more intensity of light. Okay, to get more and more light. In the case of solar panels, it is used. Okay, so the other property is the solar panels. Anything else? Yes, there are various other things, but I just told you the name of certain applications of the concave mirror. There are very much. In the headlights, you can see. Okay, there are many things. Okay, in the headlights. I think that they might be all, because there are various applications. We can write infinite number of applications for the case of concave mirror, but in the case of convex mirror, we don't have various applications. Why? Because a convex mirror gives a diminished virtual and erect image. Okay, a diminished virtual and erect image means an image of a smaller size. And where are we going to use the image of a smaller size? Yes, that's why convex mirror have very much less applications. The first application is what? First, and I'm going to tell you only one application, that is in the rear view mirrors. Rear view mirrors of your car, of your bike, of your Activa, or of your Honda, or of your scooter, of any other thing. Okay, so rear view mirrors. That's why in the case of your vehicles, on that mirror, what is written? Objects are closer than they appear, because the object size is getting diminished in this case. Okay, the object size is getting diminished in this case, and that's why we are using in rear view mirrors. Now, one more thing that I have to discuss. Is what? If you are given three sort of mirror, okay? If you are given three mirrors, okay, what are the three mirrors? The first mirror is basically a plane mirror. The second mirror that you are given is a concave mirror, and the third mirror is a convex mirror. How are you going to check without touching that the given mirror is a concave mirror, plane mirror, or a convex mirror? How can you judge without touching these mirrors? Can you judge them? Yes, we can judge them. How? What we will do, we will just take the we will just stand in front of the mirror if the image being formed is of the same size. Okay, in the case of plane mirror, you are going to get the image of the same size. If the image formed is of the same size, then that particular mirror is a plane mirror. If the image being formed of a larger size, if a magnified image is being formed, then that mirror is a concave mirror of a larger size. And if the image being formed is of a smaller size, yes, if the image being formed is of a smaller size, image formed is basically diminished, then it is the case of a convex mirror. Okay, so I think that these points might be clear to you. And today's lecture, yes, more than 1 hour lecture. It was just more than 1 hour lecture. See, my all energy gone. So because I am just providing these all things to you, you can just do a simple thing. You can just press the like button. Yes, I want that only. Just press the like button, just press the subscribe button, press the notification bell. If you just like the lecture, comment in the comment section, yes, that you just liked this lecture was awesome. If you just loved this lecture, comment me on Instagram that Ayush, I love you, and that's all. Okay, so guys, we will meet in the next one. Till then, see ya, take care, and bye bye.